Assalamualaikum and hello everyone. Okay, so today we are going to continue to discuss the next example for 4.2. Okay, so let's take a look at the example 10 here. A block of mass 3 kg is pushed up against a wall by a force F that makes an angle of 50 degrees with the horizontal as shown in the figure. The coefficient of static friction between the block and the wall is 0.250. Determine the possible values for the magnitude of F that allows the block to remain stationary. Okay, so we have a figure here where we have a block of mass. Okay, so this block of mass is pushed up against a wall by a force. So there is a force here. So this force is pushing up this block of mass against a wall. So when the force push up, it makes an angle of 50 degrees with the horizontal. Okay, so let's write down the information that we have. So what we have here, we have the mass of the block, 3 kg. And then we have the angle here. And then what else? Okay, we are given the value for coefficient of static friction, which is 0.25. So what is coefficient of static friction? Okay, the symbol for this is mu s. Okay, mu s meaning that it is static. Mu is just the coefficient, 0.25. Okay, so these are all the information that we have. And then the question asks what is the magnitude of F. So we want to find the value for F. Under the condition, the block to remain stationary. So remain stationary, same thing as equilibrium, which means the sum of Fx must be equal to 0, and also the sum of Fy is equal to 0. Okay, so first thing, we need to identify what are the forces acting on this block. Okay, so first, as usual, we have weight force going downward. And then we are already given the external force here. And since this block, okay, is pushed up against a wall, so this wall here basically is a surface. So remember, if we have a surface, we will have a normal force which is 90 degrees to the surface. So this is the surface, so the normal force will be 90 degrees here. So this will be the normal force, which is 90 degrees. Okay, and then since we are given the coefficient of static friction here, so this one means that we have friction force. Okay, so kalau dibagi value static coefficient of static friction, bermaksud kita ada friction force lah. So friction force punya direction, if the block is pushed upward, maksudnya kita akan push dia ke atas macam ni kan. So to prevent the motion, okay, remember friction dia always opposite direction. So maksudnya friction force tu akan opposite direction. Okay, opposite direction, which is going downward. Okay, sebab kita tolak dia ke atas, so friction mestilah bertentangan, which is ke bawah. Okay, so that's all the forces that we can identify. Okay, so next thing we need to do is we need to draw FBD. So you just transfer everything to the FBD here. So first we draw the X and Y axis. So we start with a dot and then just follow. We have the weight force going downward, normal force. So according to this one, normal force at x-axis. Okay, if you want to make it y-axis pun boleh, tapi lebih senang kita just transfer apa yang kita nampak sedia ada macam ni lah. And then Fs juga ke bawah. And then last sekali we have force. Okay, force ni since direction dia masuk ke dalam kan. Okay, direction dia macam ni, tetapi dia masuk ke dalam. Usually kalau kita lukis vector direction dia keluar daripada dekat tengah ni. So kita tidak boleh lukis masuk ke dalam. So macam mana kita boleh buat adalah kita start daripada sini, dia akan ke sini, which is benda yang sama. Okay, force tu masuk ke dalam, and then the angle here is the same, which is here 50 degree. So basically initially dia macam ni kan. Okay, this is the F and this is the angle 50 degree. So kalau kita sudah pindah ke bahagian ni, so the angle here is equal to the angle here. That's why I put the 50 degree here. Okay. Okay, so one more thing, you need to put the error for Fs as well. Okay, so now that we have the FBD, we need to transfer the information into the table untuk kita resolve component into X and Y. So what we have here, we have the F and Fs and W. Okay, before I can transfer everything to the table, okay, so Fs, remember kita ada formula untuk Fs. Okay, apa formula untuk Fs? Okay, kamu boleh rujuk semula, ada dekat 4.1, nota 4.1, which is Fs is equal to mu s times with n, di mana n dekat sini adalah normal force, and W, you know, is just mg. Okay, kenapa kita perlu keluarkan formula? Sebab nanti bila masuk dalam table, kita terus masuk value kepada setiap formula ni, instead of kita letak list one saja. Okay, so now kita tengok satu persatu. We start with F. So F here resolve into X and Y component. X component to the right, and it is positive. So positive F. Okay, F yang kita mau carikan tadi. So we don't have value for F. Positive F cos 50. Since angle dekat X axis, so Y component ubah kepada positive sin 50. Positive sebab dia dekat atas. Okay, next one, normal. Normal is on the X axis. So kita hanya ada value dekat X axis, Y axis dia ada value. Y axis kosong, and then since it is to the left, it is negative, and we don't have the value as well. So meaning that we need to find this one as well. Okay, and then Fs is going downward, and it is on Y axis. Okay, no angle on Y axis, meaning that we only have the value on Y axis, so X axis akan jadi kosong. So since dia ke bawah, dia adalah negative, and then negative mu s, we have the value which is this one. Okay, remember coefficient that doesn't have a unit. Okay, dia ada unit. Oh, sorry. Okay, you need to put the value 0.25 n. And we don't know. And then for W, sama juga, dia adalah di Y axis, so X axis akan jadi kosong. And since it is downward, it is negative. mg, m is 3 kg, g is 9.1. Okay, I forgot to put another one here, which is equal to 0. So this one here. Okay, let me okay, so now that we have the table here, we need to calculate this one. Okay, keluarkan equation. So mu, wait. Okay, so the sum of fx. Okay, the sum of fx is equal to 0. So f cos 50 minus n is equal to 0. So we can say n is equal to f cos 50. So we have two unknowns here. This will be the first equation. And then second one, okay, the sum of fy equal to 0. Just masukkan f sin 50 minus 0.25n minus 39.81 equal to 0. Okay, so we have the second equation. So now since kita sudah buat equation ni dalam bentuk macam ni, we can just substitute the n here to get the value for f. So let's substitute that one. Okay, and then you just solve. Boleh cari cos 50 times 0.25, and then you will get something like this, 0.766f minus 0.1607f minus 29.43 equal to 0. So you will get f is equal to 48.62 Newton. Okay, so this is the final answer. Okay, so since the question only asks the magnitude of f, okay, so you can leave your answer as like this. But if the question asks to find the normal, okay, the normal force as well, so you just substitute lah f into here and then akan dapat value untuk normal force. But since soalan ni dia tidak minta, so you just leave it like this, okay?